In this lab, we want to take a look at doing a spherical joint. Typical examples for a spherical joint are a suspension system. And right now in the assembly environment, this part goes right through, but we could add these two parts to the contact set and then go to the inspection tab, activate the contact solver, and now when I drag this, it should stop when it comes in contact with the second part. Now if you drag it too fast, it won't be able to keep up with the calculations. The contact solver is computationally expensive, so after you make sure that it works, turn the solver back off again. But let's go into dynamic simulation. So I'll go into environments, dynamic simulation, and so I have a spherical joint, and this time the motion is more than just a 2D motion, it's 3D, and I'm getting an error here, so I'm going to put this joint in again. I might be able to just redefine it, but actually I'm going to go back and check what's wrong with that, but I'll just suppress it for now, and I'll put in that joint again. So I'll do a 3D contact, and I'll select this part, and I'll select this part, and it says this already exists, even though, so I just suppressed it. I might need to delete it altogether, so let's delete it and then we'll put that in again. So I'll do a 3D contact between this part, and now I will try moving it around again. So the error is no longer appearing. I'll have to go back and figure out why that error was coming up, but you see that just creating a new 3D contact joint took care of the problem too. So with the 3D contact and the spherical joint, we have 3 rotational degrees of freedom. So we can rotate around the y-axis, we can rotate around the x-axis, we can rotate around the z-axis, but we have no translations. We can't translate in a straight line along the x, y, or z. So let's look at how to set this up. So I started a new part file, and I'm going to start a new sketch on the XY plane, and I will draw a circle at the origin, and I will dimension that circle a diameter of 1.5. I'll then draw a line across here horizontally, and I'll put the midpoint of this line at the origin, and I'm going to trim away the top of the curve, and then I'll draw another circle here. I'll trim away the top of this curve, and then I'll dimension this as a radius of 0.65. I'll then draw a rectangle in space about like that, and then I'll do a midpoint between the bottom line of this rectangle coincident to the origin, and I will dimension this as 1.5, and I'll dimension this distance as 0.25. I'll finish sketch and I'll save this, and I call this part, I named this ball with peg. I'm also going to do file save as, and I'll do save copy as, and I'm going to call this the copy socket et, and I'll save it again. So I'll do file save as, save copy as, and I'm going to name this one channel. And I'm going to put it in a different folder because we're going to use this one in a few minutes to create a point line joint. So I've created a folder called point line joint, and I'll put the channel part in that location. Alright, then I'll do a revolve, and I'm going to select this area and this area. Actually, let's just get the inside area. So I'll control unselect this area. I have only that inside area, and I'm going to revolve that about this line. I'll make that sketch visible again, so I'll turn on the visibility of that sketch, and I'll do extrude, and I'll extrude this mid-plane symmetrical by 0.25 so that it'll be a square shape. And then I'm going to start a new sketch on the front plane, on the XY plane, and I will draw a circle at the origin, and I will dimension this circle as 0.75, and we can turn off the visibility of sketch number 1. And then I'm going to do split, and I'll select that circle, and I'll select this face. I want to split that face. We'll say OK to that, so we split it on the front and the back. I'll change the color of this part to yellow, or you can use whatever color that you like. And I'm going to change this face, change the properties of that face to some other color. I'm going to copy that onto the other face as well. So I'll pick up the appearances with the eyedropper, and then with the paint bucket I will go around and drop it on the other side. I'll save this file. Now I want to make this a little bit smaller than the socket that it's going to go into. So if I turn the visibility of that sketch back on, so right now this ball is the same size as this curve, which I'm going to use this to make the socket with. So I want to make that a little bit smaller. So I could create a sketch or edit this sketch, but I think what I'm going to do is I'll do thicken offset, and I'm going to select this face and this face and this face. We can see that it's offsetting towards the outside. I don't want to go towards the outside, I want to go towards the inside, and I'm going to put 0.005. Actually, we'll go half of that distance, so I'll put 0.0025, and I want to set that offset towards the inside. Right, so now if I look at this, we can see there's a little bit of clearance between the sketch circle and the body. Turn off the visibility of the sketch. I'll save it. I'll then open up the socket, and I'm going to do revolve, and this time I'll select this area in here, and I'll select my axis. I don't want to go a full 360 degrees, so I'll set it as symmetric 180, and I'll say OK to that. I'll change the color of this part to blue or whatever color you like. I'll save that. I'll then start a new assembly. I will save the assembly file as Spherical Joint. I will place the socket, place it grounded at the origin, and then I'll do place, and I'll place the ball with peg, and I'll put that someplace on the screen. I'm going to expand the origin folders of those two parts, and then I'll do constrain, and I can select the center point of the socket and the center point of the ball, and so now we see that we have those two components in position. I'll then go to environments, dynamic simulation, and we see that that was automatically converted to a spherical joint. If we wanted to do that manually, we'll go to simulation settings, we'll turn off this automatic convert, we'll tell it no, not to keep that constraint, and so then we have to add it ourselves. So we'll do insert joint. I'll tell it I want to do a spherical joint, and so it asks me to select a point. I need to be able to see those points, and so I'll go to the assembly tab, and I can select that center point. And actually I think we could just select the spheres. Let's try that. I'm going to cancel that and start that again. So we could select this center point and this center point, but also we could do spherical by selecting this sphere as our first point and then selecting this sphere as our second point, and it will find the center points of those spherical features. So I move this around, and we'll see that it goes through the part right now. We have 3 rotational degrees of freedom, and if I go back to the dynamic simulation browser and I right click on that spherical joint, go to properties, we can see that it has degree of freedom 1, R for revolution, degree of freedom 2, R for revolution, degree of freedom 3, R for revolution. And if we click on these, it shows me that this is the first revolution. If I click on this one, this is the second revolution, and I click on this one, this is the third revolution. Alright, then I'm going to put in the 3D contact. So I'll do insert joint, and I'll go down to 3D contact. It asks me to select the first component. I'll select the socket. Second component, I'll select the ball, and I'll say OK to that. And now when I drag this, and it's not wanting to drag as freely as the previous example that I showed you, let's decrease the number of calculations, let's say to 50, and then I'm going to attempt to drag that. Right, so it's not easily dragging, and I'm not sure why. Now here it's starting to go, but I'm wondering if it has to do with the fact that on this one I use the spherical faces. So let's try to do this with the points instead. So I'm going to delete this spherical joint. I'll go to the assembly tab, and I'll do spherical again. I'll select this center point of the socket and the center point of the ball, and for some reason it's not allowing me to select that. Oh, so I'm still on component number 1, so I need to go to component number 2 to select that second point. Right, now let's go to the dynamic simulation, and I'll try dragging this now, and notice that it moves a lot easier when I join those 2 points rather than the sphere. I'll increase the number of calculations. Let's go to say 5,000. So it moves a lot more easily, even doing 5,000 calculations, if it doesn't have to calculate where the center of these spheres are. So when I selected this faces, it would have to calculate the center of the spheres. When I selected the center points, it didn't have to do a calculation. So that will be something important that we should keep in mind in the future. When we did 2D contact, we set restitution, which controlled how one part reacted to another part when it came in contact. In the 3D contact, if we go to the properties, we'll set a value for stiffness and a value for dampening, which is similar to the restitution. Think of this situation as though we had a beach ball and we held that beach ball out over the edge of a pool and dropped it into the water. When we drop that ball into the water, it's going to displace a certain amount of water, and it's also going to deform the ball a tiny amount. So that is the stiffness value. So when this comes in contact with this, there may be a tiny slight amount of displacement between the two parts as they come into contact, and then the dampening similar to the bounce. So we'll experiment with those values in future labs.